Good morning. In this video, we are going to see the fourth problem in area moment of inertia. Now, let us go to the problem. Find the moment of inertia of the following composite section with respect to AB axis and CD axis. In the last three videos, we discussed the area moment of inertia with respect to centroidal axis and the base axis and then perpendicular axis. I have given the links of those video in the description. Please kindly go through that one. But here they have given with respect to AB axis and CD axis. Now this is the composite section. Here is the position of the AB axis, okay, and here is the position of the CD axis. These two axes are separated by 6 centimeter. Now if you look the axis AB, it is similar to the x-axis in Cartesian coordinate, okay. So we have to assume that this is like an x-axis. Now the next step is you have to divide the composite section. Here there are three sections or three objects. One is a triangle and another one is a semicircle, and there is a circular hole also. So what I am going to do is I am going to add these two objects, that is triangle and semicircle. Then I will subtract circle from these two objects in order to get the composite section. Now the next step is we are going to find the values for the variables like y1, a1 and igx1. Here I have taken only three variables. Okay, why? Because here there is only one axis, AB axis. There is no vertical axis, that is y axis. So there is no need to find the values for the other two variables, that is x1 and ig1y. Okay, so it is enough to find the area moment of inertia with respect to AB axis. That means for this problem these three variables are enough. Now let us go to the first variable y1. Y1 is the distance between this AB axis and the g1. Okay, so it is nothing but half 1 by 3 of this height. So here it is 8 by 3, which is equal to 2.66 centimeter. Then the next one is a1, area of this triangle, which is half bh. So 1 by 2, 8 into 8. So the answer is 32 centimeter square. Now the next one is ig1x. It is nothing but the axis passing through this axis. So we have to find the moment of inertia with respect to this axis, and the formula is bh cube divided by 36. So when you substitute the values, you will get the answer as this one. Now the second object is the semicircle. So here is the axis AB and this is the semicircle. This is the position G2. So we need to find the value of y2, which is nothing but 4r by 3 pi, and here I have taken minus because this is in the negative side of that axis. And the formula is 4r by 3 pi. Substitute the values, you will get the answer as 1.69 centimeter. Now the next one variable is the area of the semicircle, which is by r square by 2, and substitute r, and the answer is 25.13 centimeter square. Now the next variable is ig2x, which is nothing but the axis passing through this axis. This is that one. So here is the formula 0.11 and r to the power 4. Okay, these formulas are discussed in a video. I have given the link of that video also in the description. Those who have not seen that video, kindly go through that one. So the answer is 28.16 centimeter to the power 4. The next object is this circle, and here is the position of the axis AB. You see here this axis AB is passing through the centroid G3. Okay, so y3 is now 0. There is no distance between G3 and AB axis. Then A3, it is the area of this circle, which is by r square, and in the place of r substitute 2 because the diameter is 4 centimeter. Then ig3x, which is nothing but the axis passing through this one. The axis ig3x is nothing but the axis passing through this centroid, but you see here both AB as well as G3 are coincides. Okay, so this is the position of the G3x axis. Now substitute the values and you get the answer as 12.56 centimeter to the power 4. Now the third step is to find the moment of inertia with respect to AB axis. Now the moment of inertia with respect to AB axis is equal to moment of inertia of the triangle moment of inertia of the semicircle minus moment of inertia of the circle. Here please note that here I have used subtraction because these areas to be removed, subtracted. It's very important. It's a circular hole. Now let us see the moment of inertia with respect to the axis AB for the triangle. Okay. Here is the composite section, and this is the position of the centroid for the triangle, which is being located from AB by y1. Now we know about the moment of inertia about the axis passing through this g1, which is nothing but ig1x. Okay, but I want to know moment of inertia with respect to the AB axis. Now I can apply the parallel axis theorem because these two axes are parallel to each other. Now according to parallel axis theorem, IAB, the moment of inertia about this axis, which is equal to IG1x, the moment of inertia about this axis, plus area of the triangle into the distance between these two axes. You see here it is y1, so y1 square. Okay, so this is how you have to find for the remaining two objects also. If you go to this formula, this is what here it is written: ig1x plus a1 into y1 the whole square. This is for triangle. Similarly for the semicircle, the same step: ig2x plus a2 into y2 the whole square. Okay, then minus, and this is for the circle: ig3x plus a3 y3 the whole square. Substitute the values, you will get the answer for the moment of inertia with respect to AB, which is equal to 427.62 centimeter to the power 4. The next one is I am going to find the moment of inertia with respect to the CD axis. Now you see here, this is the position of the axis CD. The distance between these two is 6 centimeter. This is 6 centimeter. Okay. So now you see here these two axes are parallel to each other, so I can use the parallel axis theorem. So I am going to use that now. ICD, which is equal to, I know the moment of inertia about this axis, so here I can write IAB plus the area of this entire composite section, which can be taken as capital A, into the distance between these two axes, which is nothing but d square. Here d equal to 6 centimeter. Okay, now A, capital A is nothing but A1, area of the triangle, plus area of the semicircle minus area of the circle. Okay, so this is what here it is using parallel axis theorem. Moment of inertia with respect to CD axis equal to moment of inertia with respect to AB axis plus A into d square, where A is nothing but, this is the formula, area of the triangle plus area of the semicircle minus area of the circle. Then distance is it is mentioned in the given data, which is equal to 6 centimeter, and substitute into this equation. Finally you will get the answer as 2032.14 centimeter to the power 4. So this is how the area moment of inertia with respect to the axis AB and CD have been found. Okay, kindly go through this video one more time to get better understanding. We will meet in the next video. Thank you.